All right, guys, this is going to be the third FRQ. Yeah. So a function f is defined by the power series f of x is equal to x minus x to the third over 3 plus x to the fifth over 5, so on and so forth, for all real numbers x for which the series converges. Using the ratio test, find the interval of convergence of the power series for f, justify your answer. So the ratio test, we used it in 2 problems ago, not in the last problem, the problem before. So we're going to use the ratio test with this expression. So we're going to use the limit as n approaches infinity of the absolute value of, now because we're using, I don't know, honestly, if the key will get me for this. I'm going to say that it's not, but because I'm using the absolute value of the nth plus 1 term and the nth term, I don't think I usually don't keep this term right here because that's negative, and so I usually just discard that right there. So x to the, but I am gonna plug in 2n or n plus 1 there, so that's 2n plus 1 plus 1, which would be 2n plus 2 plus 1, which would be 2n plus 3. So that's going to be x to the 2n plus 3 over, again, that's going to be 2n plus 3, and then times by the reciprocal of the nth term, so it's going to be 2n plus 1 over x to the 2n plus 1. And so here we have the ratio test set up, and now I'm just going to group things together. This one should be pretty simple. Those are the only thing that really going to group up. So 2n minus 2n is going to be 0. 3 minus 1 is going to be squared. So I'm going to have the limit as n approaches infinity of the absolute value of x squared, and then times by 2n plus 1 over 2n plus 3. And you can see that the degree of the numerator and the degree of the denominator are the same. And so when I apply the limit, I'm just going to focus on the coefficients, which is 2 over 2. So this limit is going to be 2 over 2, so it's going to be 1. So my limit will be equal to just the absolute value of x squared. And then I'm going to set that less than 1. I'm going to take the square root, and then I'll just get the absolute value of x is less than 1. So using the ratio test, find the interval of convergence. So the interval of convergence then would be between 1 and negative 1. So you can drop the absolute value signs and make a compound inequality of the positive and negative of the radius. So yeah, negative 1 and 1. So here's the interval, but not quite yet. We are going to come back to this because we have to test the endpoints. We have to test to see if it converges or diverges at these values right here. So let's go ahead and start with 1. So if I plug in 1 for x, what is the resulting series? So let's say for x equals 1, you're going to have this series I don't know, should I say, I'm not even going to bother with putting if n equals 0. Let me see. So when n is equal to 0, that's going to be x. So yeah, starting with n equals 0, I don't think it really matters. We're going to have negative 1 to the n times by 1 to the 2n plus 1, which is just going to be 1. 1 to any power is just going to be 1. So I have negative 1 to the n over 2n plus 1. Well, this series right here is going to be, it's alternating. So let's just use the alternating series test. So if it's an alternating series, just use the alternating series test. So let's see right here. So the alternating series test, we're going to show 1, the limit as n approaches infinity of 1 over 2n plus 1. Well, that's equal to 0. 2, we have to show that 1 over 2n, that would be 2n, the nth plus 1 term. The nth plus 1 term which would be 2n plus 3, that has to be less than the nth term, so 1 over 2n plus 1. If you need to kind of do some cross multiplication right here, you can just show that 2n plus 1 is going to be less than 2n plus 3, and that's obviously true, because then you can disregard that, and 1 is going to be less than 3. So yes, so the series converges. Series converges. So we're going to include 1 in our interval. Now we do need to check -1. So at -1, we'll get the series n equals 0. So we have -1 to the n, and then we're going to have -1 to the 2n plus 1 over 2n plus 1. Now, because they have the same base, I can add these exponents. So that's going to be equal to the series n equals 0 of -1 to the 3n plus 1 over 2n plus 1. 3n plus 1, so let's say n is equal to 1, or let's say n is equal to 0, then we get -1 to the first power. Let's say n is equal to 1. So if n is equal to 1, then we get 3 plus 1, which is going to be 4, and that's going to be an even power, so that means it's going to be +1. If n is equal to 3, what I'm getting at is that this is still alternating. Yeah, this is alternating right here, and so this is still an alternating series, and it's going to follow the same exact thing. So I'm just going to say converges by the alternating series test. And then I'm going to include -1 as well. So here's my alternating. This is the interval of convergence. Let's go ahead and check the key. And so here we have 4 points. So let's check the scoring notes. A response that includes the substitution error of the form of 2n plus 1 plus 1 appearing as 2. Oh, so this is basically saying that whenever you make the substitution of n plus 1, so whenever you just plug in 2 times by n, or 2n plus 1 plus 1, well, this results in 2n plus 2, not 2n plus 3. That's a substitution error. You have to use parentheses, you have to distribute, and you'll get 2n plus 3. So let's see what they say about that. In setting up a ratio is eligible for the first 3 points, but does not earn the 4th point. So that's actually pretty cool. You can earn a lot of points for that. The first point is earned by presenting a correct ratio with or without the absolute values. The second point, to earn the second point, a response must use the absolute value of the ratio, or resolve the lack of absolute values by including x squared is less than 1 without any errors, and correctly evaluating the limit of the ratio, including the correct limit notation. So use correct limit notation. Identify the interior of the interval of convergence. The response can use either interval notation or the compound inequality of -1 is less than x is less than 1. So I'm pretty much covering all my points whenever I'm doing it. I think I'm just, whatever I did covers all the points that you need. Absolute value of x squared less than 1. This right here, which would be the same thing as this if you don't include those right there. But yeah, I think I'm covering all the points here. The only incorrect interval eligible for the third point is 0 to 1. In this case, to earn the third point, the response needs to evaluate the general term at x equals 1. Kind of surprised that they didn't say anything about the testing. So I'm kind of curious. So when the series is an alternating series whose terms decrease in absolute value to 0, the series converges by the alternating series test. Okay, so I think that's enough. So I actually did the alternating series test where I showed 2 points. They just stated the alternating series test. So the series is alternating and the terms decrease in absolute value to 0. Because that's pretty much all the alternating series test says. So right here, this means that the limit is equal to 0, and the second term means that the terms are always decreasing. So they just kind of said that using words. The terms decrease in absolute value to 0. So by the alternating series test, it converges. That's actually really nice. I probably am going to start using that from now on, because writing this can actually be a pain. But if you know that this is true and that the limit is equal to 0, then you can say that the terms decrease in absolute value to 0. That's the alternating series test, so it converges. So that's actually cool that you can just say that. Alright, for 9, show this expression. So if you guys see an expression like this, there's been one for every single problem. So like in the previous one, you saw, this one's not as quite, but it is the Lagrange error bound. And then we saw up here in the first problem that we did somewhere, where was it? Right here. So the alternating series error bound. We might want to state that. So by the alternating, because we had to say it before, right? By the alternating series error bound. And we do have an alternating series, so we can use this. So this is the actual sum. This is the partial sum. Whenever I subtract those, I get my error, and this has to be what my error is, the upper bound, the bound of my error. So show that it's less than 1/10. So notice here, 1/2, f of 1/2. So f of 1/2, let's show kind of what f of 1/2 is. So f of 1/2 is going to be equal to 1/2 minus 1/2 to the, 1/2 to the third, times by 1/3, right? So that's going to be this term. So 1/2 to the third times by 1/3. And so notice here that 1/2 is the first term right here. So they're only using the first partial sum. That means the truncation, the first unused term, is this term right here. So they're plugging in 1/2, and then they're truncating it at 1/2, making the second term of the series right here the maximum that the error can be by the alternating series error bound. So by the alternating series error bound, the error, my error has to be less than or equal to 1/2 to the third times by 1/3, which would be equal to 1/8 times by 1/3, which is going to be equal to 1/24, and 1/24 is less than 1/10. So that should be it. Don't circle your answers. I just about did. Have I circled my answers? Alright, good. I'm not circling my answers. Alright, so there we go. We just proved that we showed that the error, this is the error is less than, the error that we have, the upper bound, is equivalent to 1/24, which is less than 1/10. So that should cover everything. Let's go ahead and take a look at the key. So the first point is earned for correctly using x equals 1/2 in the second term. Okay, listing the second term as part of a polynomial is insufficient. So listing the second term as part of a polynomial is insufficient. So not quite enough. That's okay. So using 1/2 in any term of degree 5 or higher does not earn this point, which I didn't do. To earn the second point, a response must have earned the first point, state that the series is alternating and its terms decrease to 0, and present the inequality that the error is less than 1/24, which is less than 1/10. A response that states that the error is equal to 1/24 does not earn the second point. So we've kind of talked about that you don't say that the error is ever equal to, you say that it's less than or equal to this expression, and then you can evaluate this expression as equal to and then show that it's less than 1/10. So the only thing that's kind of in question about what I did is potentially stating that state that the series is alternating and that the terms decrease to 0, which I didn't do. But okay, I probably wouldn't have gotten that point, I guess, technically. So let's make sure that you do state that the series is alternating and that the terms decrease to 0. I just feel like that's kind of inconsistent with what they had in the other question, but whatever. But we did have the other point. Honestly, I might, if it were me, well, I don't know, I can't say because I'm not grading, but alright, that's how you get the points. Alright, on to the next one. So write the first 4 non-zero terms in the general term for an infinite series that represents f prime of x. So here's f of x. Find the first 4 non-zero terms in the general term. So we'll say f prime of x is equal to the derivative of the first term would be 1. So it's going to be 1, and then it's going to be negative. So if I take the derivative of this term, that's going to be 3 out here. That's going to cancel with that. And so it's just going to become x squared. So minus x squared. And then take the derivative of the next term. The 5 is going to come down here. It's going to cancel. So you're just going to be left with x to the 4th. So plus x to the 4th. And then minus, for the next one, drop the 7. 7 cancels. It's just going to become x to the 6th. And then there you go. We'll do plus dot 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 plus. And then for the general term, so if I take the 2n plus 1, so again, this is the only term with x. All of this is a coefficient. So if I drop the 2n plus 1 by the power rule, the 2n plus 1 cancels. So I'm just going to get 2n plus 1 minus 1, which would result in just x to the 2n, and then we need the alternating part here. So it's going to be negative 1 to the n times by x to the 2n. Again, the general term is going to follow the same exact pattern as all of these ones right here. So we drop the 1, okay, we drop the 3, that cancels, drop the 5, that cancels, drop the 7, that cancels, drop the power, it's going to cancel, and then decrease by 1. So I think that should be good. Let's check with the key right here. So 2 points, the first 4 terms, and then the general term. The first point is earned by presenting the first 4 terms in a list as part of a polynomial or a series. The second point is earned by identifying the general term either individually or as part of a polynomial or series. Read as equal or as necessary. Okay. Cool. Well, I got it, so. Alright, for this last one right here. So for 11, use the results from part C to find f prime of 6. So this one would actually be really tricky if you're just like, have no idea what the pattern is here. But you can see that the pattern is that it's multiple, or you can just see it right here. This is the same thing as x squared to the n. I guess I could say negative x squared to the n because this is also to the n power. And so meaning that there's a common ratio here. If I multiply this by negative x squared, if I multiply this by negative x squared, multiply this by negative x squared, you can see that there's a common ratio, meaning that this series is geometric. And the sum of a geometric series is equal to the first term over 1 minus r. And so in our case, we can say that, use the result. So we're going to say that f prime of 1/6 is going to be equal to the first term of our series, which is 1, over 1 minus negative x squared. So that's equal to 1 over 1 plus x squared. And yeah, I think we'd be good in just leaving it right there. And so, oh, whoops. Sorry. not good notation right there. That's bad notation. I'll say f prime of x is equal to that right there. And then I'll say f prime of 1/6 would be equal to, give myself more room, it's going to be equal to 1 over 1 plus 1 over 6 squared, which would be equal to 1 plus 1, 1 over 1 plus 1 over 36, which would be equal to 1 over 37 over 36, which would be equal to 36 over 37. And there you go. So that would be the value of f prime of 1/6 and 36 over 7. So the results from part C must be geometric in order to be eligible for this point, which we said that it was, and we confirmed that it was. If a response imports an incorrect geometric series from part C, this point is earned only for a consistent answer. Cool. All right, and that finishes up all these free response questions. Hopefully this helps, and good luck.